Okay, everybody. Good morning or afternoon or night or whenever you're watching this. We are going to now talk about something called function composition. And I've been kind of lightly mentioning this phrase as we've been going because if you think about what we've done the last two lessons, we have been actually composing functions. But when we mathematically like title something function composition, like something really important here, we are usually talking about a very specific kind of function composition. And the kind of function composition we're going to talk about today involves use of the word of. We're going to use of, right? And so you've heard us say something like, f, we'll write that, right? And the way we say that is we say f of x, right? Say f of x, right? That means the function of x, right? And so usually what that means is that means you take x and you go back and you plug it into f, right? And then you solve something or you put a value in or you do something and you either evaluate it or whatever. You do something with it, right? And so what we're going to talk about is doing that with another function. So we're taking a function of a function, right? And it sounds more confusing than it is. So you're going to see this notation that looks like this. All right, so it looks like the word fog, okay, but you'll see something that looks like this and then of x. So that x there tells you that no, we're not talking about fog. We are talking about a composition of functions. The way we say this is we would say f of g of x. So you read it left to right and you actually work right to left. So you're going to work backwards on it. So what you'll do is you'll always take this x, you'll put it into g first. And then you'll take whatever this value is, and you're going to take that and you're going to put it into this. And another way that you'll see this written a lot of times that to me makes more sense is you'll see it written like this, is you'll see f of g of x, right? Sometimes they'll be proper and use brackets, but a lot of times they won't, right? And so these are interchangeable. These are the same thing. They're equivalent expressions. And this one makes a little more sense because we know that when we have parentheses and they're nested, right? You have more than one set of parentheses that you work inside out, right? And so that's pretty much going to be, I think, the hardest part about this is just making sure that you're going in the correct direction and doing this. So if you can just remember the whole kind of like working backwards way, right? Working backwards. So in other words, not how you're used to working. We're a completely left to right culture, right? So this is like a right to left thing. So you got to kind of think a little differently than maybe how you're used to thinking. So this is a visual of it that I think might be very helpful to you, right? So it says composition of functions, functions made by inputting a function into another function. And so this shows this f of g function right here. And you'll notice that it's kind of set up sort of like a what are those things called, the machines that my brain's not working, right? But it's set up so that you put something into g, right? It goes in, it does its thing, and it comes out I don't know, a block or something like that, right? You put a ball in, blah blah blah, it comes out as a cube. Then you take this output, so this is your input right here, right? And then you take this output, and then this goes in, and it becomes the new input for f of x, right? So it's input, output. If it stopped here, it would remain output, but because we're putting it into something else, it now becomes input, right? And then it comes out as a new output, and the only difference is that this output has been through two functions as opposed to one, right? And so, like I said, it's that kind of backwards engineering thinking that you got to do. And if you do that, you'll be totally cool, right? And so for notation, if f of x and g of x are functions, then you would write f and then a small dot there and then g. And it's hard. I'm going to erase this because it's not a multiplication sign. We have to really be mindful of that, right? So it's f of, so it's an open dot, g. F of g of x is a composition, and it is a composition because you're creating a function from more than one other thing. And yeah, and so that's the notation. That's sort of how we're going to work, and that's sort of an explanation of it. And I think the next video or two is going to just be sort of like pounding through a few of these and seeing how they work. All right, so thanks for watching, and we will see you in the next one.